Okay, so let's continue. There were some troubles with getting and reading the file into Pandas. So what I will do now is that I will basically show you another way of reading the data using the full file paths to that file. So that is one really common way of reading data in Python, is that you basically specify the directory path and then the file name and put that into a string and then use that to read the file. So that's a really common way. Now I just need to find the file. I guess it's under here, users with. Okay, so let's do it so that I will now clear this. Clear, yeah. And I will read the data file another time using the full file path. So I can do it so that one also really common thing to do is that you don't directly put the file paths in your read file or read CSV function, but you actually assign those file paths into a variable like fp. This kind of a magical word that is usually good to put in front of the file name, especially on Windows, is this kind of R letter, and that I will shortly explain you after I have shown you. So basically what I will do now is that I will put the whole file path. So on this computer, our data file in this is under this users /whip folder. So what I want to do is to copy and paste that and put it inside this variable like this, and then basically put the file path there. Let's see if it actually, yeah, it recognizes it still because we are actually working under that folder with IPython. So in this way we can specify the full path to the file that we are reading in, and this is a really common way of reading and specifying the file paths to the data that you want to read. What this R letter here does is that basically on Windows the folder structures are specified with this what the name of the Genoviva? /. So they are specified with basically not that one, but yeah, backslash with this letter. And you might have a folder, maybe I just first execute this one so that this doesn't get confused. But basically on Windows the file paths are specified like this, and then you have some C drive, for example, C data, like this. So why this R is important? Because you might have a folder called new folder like this. So unless you specify this R letter before, this \n would be, so the computer would understand it as a new line, because with this \n, actually the computer, you will insert a new line at that point. So that is kind of a problem when we try to read the data from certain locations such as this. So this R does so that the computer doesn't actually interpret that those escape characters such as \n, \t and so on. So that is the reason why we, especially on Windows, want to do that kind of operation when specifying the data files. So, but now let's continue. So I want to read the data again to this data frame variable, and how I do it is pd.read CSV. Then I specify what is the file path that I want to read. So it's the fp. So instead of putting the actual full file path there, I just put the variable name here. And then what I want to do is that I can, well, we know already that the kind of delimiter or the separator between columns is comma in this case. So I can specify that. This is also something quite useful. You might have files where there is a semicolon, for example, to separate the different columns. So with this sep parameter, you can specify that it's a colon or it's a semicolon or whatever. So we specify that, and then we had the kind of metadata on top of here. So we again want to say that skip rows. So we skip the first lines in there, so the first 8, and now we should be able to read the file into Pandas. And let's see. So data frame, I just now print it out, and yes, we seem to have clean data. So it starts from the 1st of June 2016, and we have 29 values as we should have.
If anyone's having problems still with reading the data file, just if you let me know and I can try to help.
Yeah. So maybe I still move forward. So one really kind of typical things that you want to do with your data when doing analysis with your data is, of course, that you want to create new columns into your data frame. And how we can do that is that we can basically create it in a really easy manner. So how you create a new column is that you specify the data frame that you want to create it to, and then we put inside these square brackets the name of the variable that you want to create. And in this case, I will create a new column called Diff, and I will assign some default value for it. It can be anything. It can be value 0, it can be none, for example, like this. So it would be basically no data values in that case. But I want to put in this case a value 0.0 into this diff. And what we can now do is that we can actually see what comes out. There is a really good function called dataframe.head, and what this does is that it actually doesn't print out the whole data frame for you, but it only prints out the first 5 rows, and that is usually enough when you want to just check a little bit what happened in your data frame. So what we now have here is that I indeed created this new column diff, and yeah, it appeared here, and we seem to have these 0.0 values with all the rows in that new column. So this is what happened in here. What is kind of a good thing to know is that when we now print out the data types, so we can print out what is the data type of our new column. So we can specify it like this. So data frame, and inside the square brackets we specify that I want to know the data type of that column. So data frame square brackets diff dot dtypes. And in this way we can just check that, okay, the data type of that one column seems to be float 64. So Pandas kind of automatically identified that the value that you inserted into that empty column or new column was floating point number. If you would have put it integer value, it would have basically defined the data type as integer, and if you put a string, it would identify it as string. So kind of Pandas know these things automatically, which is quite nice, and something different, for example, when compared to NumPy, which is kind of running in behind. Of course, well, now we just created an empty column, but what we usually want to do is to make some kind of calculations. So we can update the same column that we just created by just specifying it another time. So data frame diff inside the square brackets equals to, and how I can do calculations is that I just specify that what columns do I want to use in the calculation procedure. So I could, for example, calculate the difference between the maximum value temperature for the day and the minimum temperature for the day. So to get the difference between those values. So let's see how we can do that. So again, I define that I want to update the data frame diff column, and how I want to update it is that I actually calculate the difference between data frame max column, so these values, and take minus data frame min. So we have those two columns in our data frame, and it's really easy to do this kind of calculation with our data. And when I press execute, enter, then we actually have updated the values in our data frame. So now you can see that basically the difference, the maximum minus minimum value on this row is 18.9 and so on. So it's really easy to do these kind of calculations between different columns in your data frame. And of course, let's see. Yeah, and basically one thing to understand is that you don't necessarily need to create that column that you are what you are calculating before you actually do the calculations. So we can, for example, do data frame, create a new column called diff min, and we can calculate the difference between data frame, come on. So let's take the subtract from the temperature the minimum value temperature for the day. So just like this. And now we should have that kind of column in our data frame. And yes, so we actually, just to clarify that you don't need to specify the variable before you are doing the calculations. It can be created and calculated on the same command. And of course, you are not, what you can do, how you can do the calculation is to use any kind of math algebra basically. So you can, for example, calculate, so the temperatures here, they are Fahrenheit, and we have done already few times converted those temperatures to Celsius. So now we can do it directly, just specifying the column and the formula to do the conversion. And let's see how that is done. So I will create a new column called temp Celsius, and then in that column I will basically specify the formula. So what is the data that we use as an input is the data frame temp. So these are the temperatures in Fahrenheit, and the formula for doing the calculations was that you want to subtract 32 from that, and then divide those values with 1.8, or in the materials we have 9 divided by 5.
Could you just import the function that you already made before?
For sure, yeah. Basically, you can do that. I don't know if Yeah, there you might need to use specific tricks to actually use that function, and we are going to see that on next week how to do it. But yeah, of course you can do it, but this is kind of a really straightforward way to do the same thing. So now I use this kind of a specific formula to calculate and convert the temperatures, and indeed what we have now is that it calculated and converted the Fahrenheit temperatures into Celsius for all the rows that we have in the data. So quite straightforward thing to do. One really useful thing when you are working with data is that you want to, most probably at some point you want to select some rows from the data and do some operations with and apply the operations only for those rows. So we have already seen how we can actually take some items from Python lists and some ranges from a Python list. So actually we can do pretty much similar things with Pandas. There are a little bit more advanced ways of doing things in Pandas, but the really basic thing, how to, for example, get the first 5 rows from a data frame, is that we specify a variable. So I create a new variable rows5, so 5 first rows, and then I said data frame, and then inside the square brackets I said that I want to get the from 0 up to 5, and let's see what do we have here. So when I print out, so indeed now we have the first 5 rows inside this new data frame. So when we actually check the type of that rows 5, we can see that we are still having a data frame that we can use all the functions that we are now showing you. So that's kind of neat. There is more explanation how you actually specify these selections in the web page, but maybe I just move forward. Of course, you can also just take a single row from the data in a similar manner as you would take a single item from a Python list. So you can also do that same thing in Pandas. For that, there is this kind of special way of doing indexing and slicing in Pandas, and I will now show you that. What I want to do is that I want to take only the 8th row from the data that we have here. So I create again a new variable called row8, and inside that variable I will insert the row from position 8, and it can be done like this. So we have this special command called .loc, so it's kind of location in indexer, and we specify that I want to take the content from this position 8, and let's see what do we have inside. So indeed now what we actually have here is that we have all those values from different columns inside that row8 variable, and what is actually the type of that variable that we now did is that, okay, instead of data frame, now we have these Pandas series. So you can think series as a list of values, and how you can basically get a certain, or do we want to do that before? Yeah, maybe we do. There is actually at this point a question for you again. Not in here.
Yeah, you can just put it on the, put this up on the other screen.
Yeah, maybe so.
Because the question is here.
Yeah, then we need to change that. So now you can again go to the polling site and we will show you one question. Not that one.
It's up already.
Oh, cool. Turn off the screen.
Yeah, that's it.
Oh yeah, okay. Yeah. So what output would print data frame .lock -1 produce? So as you might remember, when dealing with Python lists, you could get the last item by specifying this -1. But what if we do it in Python? There is one answer here. Well, no, already 3. Okay, we need to have a unified opinion that it seems to produce a key error. Not. We have some other options as well. Opinions.
And I think similar to how it was before, I've just separated things that would be printed on separate lines with commas, and then just ... after, because there's more output than what's shown here.
Yeah.
So let's see if we can maybe get up to, I don't know.
Yeah, when we get 12, then we move forward. 3 more to go. Good. Come on, you won. Yes. Cool. So it seems that the majority of you thought, let's see how many. 7 of you thought that we will get a key error. Well, we can for sure actually check that. So the question was, what would you get if you put lock, use the lock indexer and put the -1 in there. So let's see. Indeed, it seems that it doesn't work. So this is something different in Pandas data frames and these indexers, that you typically, these doesn't work, so you cannot actually get the last item in this way, which is similar to Python lists. What you could do to actually get it is to actually use, there is this comment head to get the first 5 items, for example, but then there is this other comment, data frame tail, and then you can basically say that I want to have the last 1 item from the behind of the data. And this way you would basically get the last item from that data frame. So just to know that you don't get confused, because this is behaving a little bit different than.
Yeah, and I don't think we'll see it today, but the reason why this -1 index behaves differently in Pandas than it does for a Python list is that you don't necessarily have to have a number as the index value in Pandas. So putting in -1 would maybe perhaps make sense if we do it, think of it like a normal Python list where things start at 0 and go up. But in Pandas, as we'll see maybe next week,
Yeah, probably.
there are other ways to index your data that are not necessarily just single number values starting at 0 and increasing by 1.
Yeah, actually also this week we are doing that. But how we ended up here was that we showed the row 8. So what we did here was that we have the I used the .lock 8 to get the 8th or the items from row 8, and how we can actually get these actual values. So now we have a Pandas series showing all those, but you can actually assign to the, or refer to the index value So basically what we are having here is that in here you have the index and then you have the value. So what you can do is that basically if you want to just check that value, so the year mode A, year month day basically, is that you specify it like this. There is another way of doing it that is shown in the course materials, but just that you know that this is something that you can do. Of course, using this data frame.log, it can be really useful because you can specify that I want the rows from 5 to 10 and I only want to take one column, so the values from certain column only. And we can, for example, take the temperature values, so we have the Fahrenheit temperatures, and say that I want to call rows from 5 to 10, so at those index positions. And how I do that is that I specify the temps 5 to 10 equals to data frame dot log, and then inside here I said that I want from position 5 to 10, and then comma. So now in basically here we can specify that from what column do we want to get those rows from. So here we specify that use the temperature column and print and return those values. So what we have here is that indeed we only have now a Pandas series showing those temperature values that are somewhere here. You can also not only take one column, but you can specify that I want the temperature and then I want the temperature Celsius that we just created before. So actually you can pass a list of columns that you want to take from here. So in this way we can say that I want the Celsius. So I want to have the columns temp and temp Celsius from those positions, so from index 5 to 10. And let's again see that, okay, now indeed we have those index values and then we have the temp and temp Celsius in here. So that can be quite helpful when you just want to select certain parts from the data. Of course, quite often, the most cases, you don't want to specify certain index ranges, but you actually want to have the whole columns. So select the whole columns from the data. And that can be, of course, done also. And it can be done easily by just specifying the temps only. So now I will only select the temperature values from that data frame. And that can be done by saying the data frame, and inside the square brackets I specify a list of columns that I want to take from there. So temp and temp Celsius, like this, and it should work. And let's see, temps only. And yes, now we have the whole 30 values from the original data frame inside here in this variable. So this is really a common thing to do in Pandas. Then something really useful. So now you have seen how you can select some data based on the index values in your data frame. But quite common thing that you want to do is that you want to kind of, with certain criteria, you want to select some rows. So for example, I want to get the rows from the data frame that we have where the temperature, Celsius temperature, is above 15 degrees. This is something that is quite often needed to do in many data analysis works that you might do. So there is a special way of doing these kind of selections in Pandas, and I specify that VW temp, so warm temperatures, and I specify now that for me the warm temperature starts from 15 degrees as we are in Finland. So let's say the data frame, and how you can do this query in this case is to use this kind of command called x, and inside that in the square brackets, so you are kind of creating a new indexer, so it's kind of a shortened version from that, and inside here we can say that select those kind of columns or rows from the data frame where the temp Celsius is not that one, is larger or equals to 15. So this is kind of a format how you can just select certain rows from the data frame by specifying some criteria. So the criteria, so you need to specify that the temp Celsius in this data frame, so the same data frame that we are actually working on, is larger or equals to whatever temperature or whatever criteria you want to pass. So this invalid syntax, okay, yeah, I have too many square brackets here. So okay, x is deprecated. This is interesting. This is something that doesn't come up with Windows. It doesn't matter, it should work still. So now what we have in this wtemps is that indeed we have values, only those rows where the value is above 15. Of course, you might want to select so that the temperature needs to be above 15, and then you have some other criteria. And with this Pandas tool or the function x, need to see if we need to update our materials, but we can also specify that I want to have those rows where the Celsius temperature is above 15 and the days should be basically from the second half of June. So in this, you can't see that. So from, let's go here. So this year, month, day column basically has the values of the days or the dates in 2016. So 2016 in June and the first, second, third, fourth day of that month and so on. So what I want to do here is to actually take those values where the date is larger than or equals to the 15th of June. So take the second half of that month, and only those rows where the Celsius has been larger than 15 or above 15. We can continue working with the same command here. So how you can kind of chain these criteria is that you use this @ character if you want to make a kind of and, use the and operator for doing the criteria. If you want to use or operator, so these are something that we practice during the conditional statements. So if you want to do the or, so you should use this character, whatever that is in English. Well, this straight, yeah, this vertical bar. But those are the ones that you want to or can use. There might be more, but those are the most typical ones. So now, as I want to include only values where the temperature is above 15 and that the date is above 15 as well. So I can do it by specifying another criteria inside here. So the data frame, now I just want to, yeah, it's year moda. So year moda is larger or equals to 2016, 6 and 15. So 2016 is the year, 6 is the month and 15 is the day. So in this way we can actually get the temperatures only for the second half of the month. And as you can see, now we only have those values that are above the 15th, whereas here we had also values from the first half of that month. So something really useful to know and learn how to use in Pandas. Then there are, in the exercise, you also need to deal with missing data. And that is something that I will now show you. Quickly. So before we actually can show how to deal with missing data, in our data frame here we actually don't have any missing data. So I will first show you how you can actually update certain rows in certain column and put some values there, which is of course something really useful as well. For that purpose, I will modify this wtemps2, so the second half of the temperatures that we just did. And how we can basically assign and update some values in our data frame is to use the same .lock command that we already saw before. And I want to update the first 5 rows. So in this temp Celsius column. So in a similar manner as when we selected some data, so now we actually say that wtemps2.lock and inside the square brackets colon 4. So this is equal to 0 until 4, but you don't necessarily need to actually put the 0. This is something that also might be something useful to know. And then what I want to do is that I will do some stuff with the temp Celsius, and when I want to update those values is that I just say that wtemps2.lock temp Celsius equals to, so now when I say that equals to none, so I will actually update those rows in that specific column temp Celsius. So if you actually want to update the data frame, you need to specify it wtemps2. And now we should have the, yeah, now the index is correct. And the third time, if it now doesn't work, then I don't know what I'm doing here. Teaching you. Okay, now it works. So finally, we have some missing data in our data frame. So now you can see that there is these not a number signs here. And these are problems that you quite often face when dealing with real data. We also have during this week this kind of situation where you have some no data values in your data frame. There are basically 2 approaches, common approaches how to deal with missing data. The first one, and maybe the safer one, is just to remove those rows where you have some no data in some specific column that is important for your analysis. Let's first see how we can do that. We can remove these kind of no data rows I just create wtemps clean. So what we are actually doing here is that we clean the data from no data values, and there is this command called drop NA, so drop no data values. So what I'm now doing is that I want to drop from that wtemps2 data frame these rows where the temp Celsius column contains some data, some no data values. There is this parameter called subset, and inside here we can specify for this function that check the no data values from this column, so from temp Celsius column. By default, if you don't specify this, it would check all the columns in your rows, and basically if any of those columns has no data values, it would drop that. So it's quite important that you specify the column that you are searching for, and those columns, possibly there are many columns that are important for your analysis, so you check and remove those no data values. So this should now work, and let's see what do we have. So we have wtemps clean, and indeed now what happened is that we removed those rows where there was the no data values, and we have the clean data frame for doing that. Other not so it's a bit more risky way of doing is to actually fill those no data values with certain value that you choose. So we can create another called vtemps filled, and now instead of using this drop NA, we can actually say that fill NA. So in this case we will fill all the values in our data frame with the value that we choose, and I choose to do this now with value 0. So let's see what we have in this case. So filled. So now the original data looked like this, as you might remember, and now in this case what we did was that we filled the data, those holes in our data, with the number zeros. This is can be dangerous. For example, in this case, if we would now take the mean temperature from these days and we would have these 0 values here, so of course our average temperature would be much less than it actually is. So you need to be kind of careful and understand in what kind of situations you can actually use this fill command. Yeah, then there is a materials about how to sort values. There are, of course, you can sort the values from ascending, like temperatures from the lowest temperature up to highest one, but maybe I now skip that. You can go and check from the materials how that can be done. It's quite straightforward and easy to do. One last thing what I will show you, well actually two things quickly, is to how you can actually round values. So it's just one simple command that you will need to use also in the exercise. So we have this data frame and we have the temp Celsius values that are having multiple decimals here. So what we could do is that we can actually round those values and specify, for example, that I want 0 decimals or 1 decimal and so on. So that can be easily done by, again, we can create a new column to our data frame. Let's call it Celsius rounded with like this. And then what do we pass there is that we take the data from column temp Celsius. And what do we want to do for that is that we want to round it. So there is this function called round, and inside here you can specify that I want 1 decimals, 2 decimals, or zeros. And I will now do it with 0, and as a result I should have these values now rounded, and this is quite useful in many cases. The last thing, of course, you might quite often want to save your data back to this, so back to your computer, and that is also easy to do. So after we have done these calculations in our data frame, we might want to save the output to a CSV file, for example. So let's see how we can do that. First of all, when you read the data or write the data to disk, you need to specify the file path to which file you want to save the data, or from which file you want to read if you're reading it. So let's first define the output file path. So in my case, I want to save it into the same folder where I actually read the data. So I just copy and paste this file path that Dave has. Again, just that you remember, especially Windows users, use the R in front of your file path, and then specify that I want to save it into Kumbula temps June 2016 .csv. So in this phase we only say that I want to save it into this location in my computer. We don't do anything yet. And how we can, for example, save this data frame here that we have is that our data frame actually has this nice function called dataframe dot to csv. And it has some parameters, so of course we want to first specify that I want to save it into this output file path that I specified here. And then what I want to also specify is that the columns should be separated with comma, colon. And then what it does, it doesn't print anything, but now we should have, if we have the file explorer here somewhere, how can I get that?
I mean, you just want to look at
yeah, cool. Oh yeah, we have this one as well. Cool. Yeah, so now what happened was that we got this kind of file. Can I even double click this? Ooh, yes, I can. So this is the result that we got. So we actually saved our data frame into this file. What you can see here is that it didn't only save the columns that you have, but actually in the first column here you have the index of the row that you have, and that might be useful, but for example I usually don't want to have that index value in my data frame, so I want to actually remove that. Other thing to notice here is that you have quite a lot of decimals in these values. There are nice tricks how to actually deal with these things, and that is the last thing that I want to show you before actually going to the exercise quickly. So basically we can create another output file path. So now I will save the data frame where we had the temperatures above 15, and now I will save those temps. I will change the file path here, so above 15. So now we should create a new file in there. And how can we do this stuff without the index and with the rounded decimal values is that we use the to CSV. again we specify to where we want to save it, so to this file path here. Then I want to again use the separator as the colon. Then how I get rid of the index in our output file is that I set the parameter index equals to false, so don't use the index. And how I can format the decimals there is to use float format equals to, this might be looking a bit fancy or interesting for you, but in this way we can say to Python and Pandas that round the values using 1 decimal and it should work. So now what happens, yes, we have the temperatures above and we have much cleaner looking output file in here. We went quite fast these things, so it's not, you can go and check the video and hopefully you will get a better idea. There is in the web page there is a kind of hint how to save to Excel file this stuff, so you can also check that. But unless there is something urgent questions about the stuff, we could quickly go through the exercise 5. No, so let's just do that then. Again, we have here the exercise 5, and you can take the classroom there and start working. So I kind of did what you asked. So basically we have more problems this week, but they are basically a bit simpler, at least in the beginning. So you basically need to use different data. So what we are using this week, in this week exercise, is that we have this weather data again from 2 different places in Finland, so from Helsinki Kumpula weather station and in Rovaniemi. So, and what we are interested in is to actually compare the kind of summer temperatures in these 2 places and how the summer temperatures in Rovaniemi have differed from Helsinki and so on. There's a kind of explanation here about what are the columns in this data file. One important thing to notice is that we have these star characters here, and those are the no data values in our data. And when you are reading the data in, you need to deal with that. There is basically a certain parameter that you need to pass to the read CSV command, and there is basically explanation how to do that and how to specify it, so then it should work. Using these kind of star characters as no data value is quite rare. This is the first time that I see them, and yeah, and that is kind of a little bit trickier to actually deal with them in this case. But now, as said, we are working with real data, so you might get different kind of data files when you are taking it from somewhere from the internet. So this is kind of real situation that we have here.
Maybe just one brief thing to add, because I know we're running low on time, but in some ways this is a nice example because we have this sort of unusual way of representing the no data. Because what we end up doing here is you basically have a list of all the things that if Pandas encounters 1 star, it should convert that to not a number. If it encounters 2 stars, it should convert that to not a number, and so on. It is definitely unusual, but it's kind of nice to do it this way because more often the case would arise that you might see something simple in class, and then you get out into the real world and you encounter this, and you have no idea how to handle it. So yeah. This is, in some ways, nice. There are occasions maybe where different characters would be used to represent, both representing no data. So now you have some way of kind of making sense of how to convert these values to NaN.
Yeah. So still something about the data. So it's kind of a similar to what we have seen already during the lesson. So we have the kind of date information, then we have the temperature in Fahrenheit, maximum and minimum temperature. But in addition, we have the station ID. So actually we have the data for Rovaniemi and Kumpula. They both are in the same data frame. So they are just one in the top and next to the below that. So what you need to do is to actually at problem 3, you actually need to separate those rows for Kumpula and Rovaniemi into separate data frames and save those files. And then basically what we have here is that we do this kind of simple data analysis. We have plenty of questions that you need to actually find the answers using these methods that we just showed you. What is the mean temperature for this whole data set for Kumpula, for Rovaniemi, and so on. So it should be kind of quite straightforward exercise to do, just following the stuff that we showed in the lesson. There are also hints in the hint page, not here, but here. You can go and check. There is one hint that might be useful when you are kind of trying to get certain values only from certain month. Then there is the optional problem 5, which is for more advanced students. And basically, now this is done that we gave just a really few things that what you should do, and then you should find yourself information how to actually do that. So what we want to do here is that actually, as we have the data, so we have the temperature values for each hour, and actually every 20 minutes we have one value. So what in this optional extra tasks you need to do is to aggregate the data so that we have the mean temperature for each day instead of having these kind of 20 minutes intervals. So I think it's something quite common that you need to do when you are doing data analysis. So kind of calculate the averages from certain range of data values and do stuff. So that is kind of something for the more advanced students with programming background already to kind of do. Yeah, and as always, if something comes up, I'm quite sure that there are troubles in the exercise instructions as always. So we are really happy to get your feedback, and we try to correct the mistakes right away when you just specify them. So it's kind of, as said, we are having a learning experience here as well.
And just as a reminder, please post those questions in Slack if you have them so that everyone can see.
Yeah, exactly.
One last thing one thing I forgot to mention in the course feedback earlier was about the videos for class. There was a request that they be posted on the same day that we record them, and to the degree that that's possible, we'll do that, but it takes about 4 hours for the video to be encoded and about another 2 hours for the video to be uploaded if I have to do it at home.
And then 1 hour to actually put them on the webpage
and
add some links.
Usually I upload the videos at night and then add the links in the morning. So if we can, we'll do it, but normally I can't get to this stuff until the evening, so sorry about that. We do it as quickly as we can.
Yeah.
Okay. Anything else?
Yeah.
All right, see you next week.
See you next week.
Sorry, I just wanted to not forget to say that.